welcome to the DANS people who are present here to listen to another seminar to be presented by Slava. Slava, who has always been propagating not just Dataverse, but also the let us say the additional possibility that it has to offer, and promoting that we make use of those additional possibilities. And here today he's going to talk about the Metaverse for Dataverse, building a collaborative machine learning platform for the Dataverse network. So Slava, I would like to give the floor to you, but only after saying that we are going to record this presentation. And if anybody objects to that, this is the moment to say so. But I don't hear or see any objections. If you have comments or questions, please put them in the chat, and I will keep an eye on that. And after the presentation, we will have the chance to discuss those questions and remarks. So again, Slava, well, also let me say, of course, these times are very difficult for you, and I admire you a lot that you have apparently found the possibility and the concentration to prepare this this meeting, because it must be very difficult for you to see what is happening in your country of origin. And I wish you all the best with that, and have great sympathy for you.
Thanks, Peter. So I already published a link to slides, so you can find it in chat. I hope it works. So let me know if it doesn't work, and I will share it again. And I will share my screen.
It works, I can tell you.
Okay, that's great. So you should be able to see my screen now. Can you see something?
Yeah, I can see it.
Okay, thanks. So yeah, today my presentation today will be not very well traditional for me, I would say, because I will not go too much into technical details, and I will try to actually explain my vision about future archives. And I spent last decade working on archiving solutions, and I have some interesting ideas, I think, that I want to share with you. So today we are going to talk about Metaverse for Dataverse, and it's actually called, this presentation is called Building Collaborative Machine Learning Platform for Dataverse Network, but probably you will hear much more than that. So I think everybody heard this word, Metaverse. It's kind of emerged now, and it's not only started with Mark Zuckerberg Facebook, but it was there before. And I just took this definition from Wikipedia, where it stated that Metaverse is a network of 3D virtual worlds focused on social connection. In futurism and science fiction, it's often described as hypothetical iteration of the internet as a single universal virtual world that is facilitated by the use of virtual and augmented reality headsets. So you can quickly think that this is kind of science fiction, and that's something that doesn't exist yet, and it's really in the starting process. However, there are a lot of components that are quite ready for Metaverse, and I also believe that, for example, Dataverse can be used a lot for this technology. And second definition here is about access points that could be used for Metaverses and include general purpose computers and smartphones. This is where you can see cloud computing, and you can see storages in Dataverses, and you can see a lot of other applications like augmented reality, mixed reality, and virtual reality. So let us think about the archive of the future, how it can look like in 10 or probably 20 years from now. And I really believe, and this is why I specifically put open science in this slide, that it's not possible to create something like Metaverse without using open science. So all these big companies like Facebook and Google, they have quite limited resources, and they are not able to produce all these virtual objects without involving society. So open science should have really a critical role, should play a critical role in this development. So you probably saw this slide. It's about how open science is emerging. So now we also have citizen science. So we have people that just come into science and they're helping this with some scientific developments. They're contributing their time and they're helping researchers, scholars. So basically in this picture, we see large digital infrastructures, and that's something they're building in different projects in Europe and also worldwide. We have publication systems where all papers are getting published. We have all metrics like altmetrics mentioned here. But we also see a lot of social inclusion. So if some people publishing results of their research, there is discussion on happening on Twitter, on Facebook, on different channels. So people just basically contributing and they're delivering feedback. So this citizenship actually allows to get really nice feedback that can improve any research. So the question here, how we can improve all processes and how we can make open science even better using all people that have resources and wish to contribute to it. So probably some of you heard about Time Machine Project, and I specifically put slides on it because Time Machine Project is kind of, you can easily imagine that Time Machine follows all these Metaverse rules, because the intention is to build international collaboration to bring 5,000 years of European history to life. And it's about digitalization of historical documents, of millions of historical documents. And the idea that some largest possible simulation will be created where people can go back in time. They can decide if they wanted to do some research on Middle Ages or on, let's say, Napoleon time. They can just use this simulation and they can get access to all data available about this specific period of time. So this consortium is kind of emerging now. It has more than 600 people, members, and it's basically, it's doing a lot on the population of developments on big data, artificial intelligence, and augmented reality. And in a way, Time Machine Project is very close to the definition of Metaverse. And of course, it's difficult to imagine that we can build Metaverse without semantics. So that's something that we really need to do more, to create all relationships between all materials. And basically, we can think about new internet, which is kind of Web 3.0. And Web 3.0 will be built on a decentralized blockchain protocol. There is no centralized ownership of content, services, and platforms. And of course, with semantic rules, could be used as kind of underlying technology also to build Metaverse. And it's also very important to understand that it may be special in nature. So our traditional internet that we use now is mostly offering a two-dimensional experience. So we have browser, we are able to browse some web pages. But in the future, it's easy to imagine that you will use some headsets like Oculus or whatever. And you can just basically use virtual reality to browse through all available resources that link with semantic relationships. And you can use your voice, you can use some biometric commands and other things just to navigate inside. Another thing that I really wanted to show you, probably not all of them know what is NFT, and NFT is kind of emerging technology now. It means non-fungible token in Metaverse, and non-fungible means basically non-replaceable, and this is roughly corresponding to persistent identifier that we all are using for academic purposes. So Metaverse is a future evolution of internet based on persistent shared virtual worlds in which people interact as 3D avatars. So this is basically not possible without persistency. And I really think that our work on persistent identifiers is really helpful and valuable in this respect. And blockchain technology may provide a backbone for Metaverse. So, of course, interoperability is on the first place. So we really need to think about semantic interoperability, because we want to move the same object into different Metaverse spaces. So question here, how can Metaverse be created without common fair principles? And that's something that is a central question, I think, in my presentation. And some technologies like Dataverse, they could be easily replaced with other technologies, but principles should remain the same. And this is very important. Okay, so now let's imagine that we have thousands or hundreds of thousands Dataverses or something like Dataverses deployed as a nodes in distributed network. So they will form this network where you can query and you can search in all of them in standardized way. So basically, we can think about some solutions that will allow to distribute ownership and create relationships between different objects stored in different nodes. And we can, with the blockchain, we can get access to all of them following specific rules. And before, so we had this standard response, and we had data repositories like Easy, traditional repositories where we just archive materials. But now we want to explore materials, we want to get access. And this is why semantic interoperability should be implemented on the infrastructure level. So basically, every node should talk the same language to other node. So all of you know our vision of DANS about future data services. And basically, we already started to work on this nice vision where we have the same technology, which is Dataverse, and it has a lot of APIs, and it's perfect for open innovation. But what is happening now? So we created a so-called archive in the box solution for Dataverse in a SSHOC project. And now it's been installed in Claria, and it's been used in Odyssey, and also it's been used in EOS Synergy and in other projects. So basically, this technology is emergent, and it's the same technology. So it means that it's maintained in central place by Harvard and by other people, by community. And basically, we can add any kind of community-based customized components. And it just works on the generic layer as a common infrastructure. So we are taking this conceptual approach. We started to contribute semantic-based components to Dataverse. And it's mentioned here, it's semantic API that was contributed in the release 5.6. Released, I believe, in August. And this is really important development, because now we can talk language that Semantic Web actually uses. So we're using JSON-LD. We can create data sets, just sending JSON-LD to Dataverse, and we can download it back as JSON-LD. So it's basically, we're talking about RDF that people can just download from Dataverse. And second feature that was also added recently in September, it was integrated in Dataverse. It's something that our team did in SSHOC project. So we developed external control vocabulary support. And this is very important functionality, because now we have possibility to link all content stored in metadata to control vocabularies that people want to use. So now we have Cosmos integration. It was our first prototype solution, and also community started to use the same technology to connect to other control vocabularies. So for example, Global Dataverse Consortium already integrated with CoOrchid, and Belgium Archive, they started to use their own persistent identifiers for researchers. So it's basically, it's in different countries they started to use this technology, and now it's also emergent. And as a result, we'll have a lot of concept URIs. We have a lot of linked concept in metadata. So, well, you probably saw this functionality in action, but just to remind you, it looks like in this form, you can type for a few keywords and you'll get a list of suggested terms. So you can select something and after it will be added in metadata. And even more interesting about this process, there is functionality implemented in Dataverse that does archiving of concept. So it will go to concept URI and by API, it will download all translations, all available links for this specific concept, and it will index it. So people can also find it by searching in different languages in Dataverse. And for example, if you will create metadata in Dutch or in Finnish, you'll be able to find it with search queries in German or in Dutch, doesn't matter, or in English also. So this is really important functionality, and that's basically the beginning of a semantic search. And if you think about hundreds of thousands Dataverse instances available as a nodes, so we can combine all nodes together and we can query the whole network. So it's basically we are solving multilingual problems, and we can deliver to researcher a lot of new materials about specific topic. So I already mentioned archive in the box, and that's something that we created in SSHOC project. So we basically we developed two different possibilities to install it. The simple one is just to use Docker module, which is available on most of operating systems. And second is Kubernetes. So this is for advanced users, so they can just get Dataverse installed out of the box without any efforts on their cloud, and doesn't matter if it's Azure or Microsoft Azure or Google Cloud or Amazon. It works everywhere. And just interesting details about this archive in the box. There are a few things that are new. So, for example, there is possibility to create Dataverse distributions. So basically, it means if you have your community requirements specific to your community, you can also integrate your own components together with Dataverse, and you can integrate this pipeline. And this is very valuable because Claria and Odyssey and others, they can build own distributives, and they can exchange these components with other communities. So it's also can speed up innovation in a good way. So I already mentioned external control vocabulary support. So now we implemented Cosmos framework as a standard interface. However, there are a lot of possibilities because it's really universal. So it could be basically used as inspiration for other data repositories like DSpace, can easily integrate it with JavaScript solution. We also started to use Min.io storage, and this is also very important because now we've got cloud storage support, and we can store data not only locally, but we can also publish data. We can send data to any cloud providers. I already mentioned like Microsoft Azure, Google or Amazon. So all of them have a standard interface, S3 based, and we can use them to send data everywhere. So there are also data previewers integrated in this distributive and some cladding components. And we also try to tackle multiple languages support. So we also implemented WebLate as a service, and people started to translate Dataverse interface in different languages. So again, building Dataverse distributions should be easy for you, and currently we're working on documentation how to do that. And what meant about distribution? So software distribution is a process of delivering software to end user. And if you think about Linux, so Linux has a lot of distributive distributions like FreeBSD, Ubuntu, Red Hat, or wherever, Fedora. And basically with Dataverse, we started to do the same. We started to package software that unique for specific community, and still there is a common component, the Dataverse, that basically can be placed in the middle of any pipeline and start to store data with metadata and basically produce fair data sets. So that's something that people started to use in EOS projects as well. So it's emerging, and there are a lot of benefits for this common data infrastructure. As more people will join, less expensive it will be, because a community will work on the same solution, and it will be contributed to the same Dataverse community, and also it could be basically distributed for other people from other communities, even from other continents, if they will see some value in the functionality that we're developing. So this infrastructure is distributed, like I already mentioned a few times, and it's really suitable for the future. And the use of same infrastructure components will enforce the quality and speed of knowledge exchange, obviously, because you can free a lot of maintenance hours and maintenance time, and which means money that you can invest in something like research and development or in other processes. So in the end, it will be much less expensive. And I would say this common data infrastructure plays a role of universal gravitation layer, because if you imagine a Dataverse is being integrated in any workflow, you can see a lot of data sets coming to this network, and this metadata description, rich metadata description. And that's something that people can use immediately after data sets are being published. So I already mentioned Semantic Web. So in this way, we are supporting Semantic Web for data. So historically, most of data sets preserved in data silos in archives, and there are cultural, structural, and technical challenges. So this is why it's really important to work on linked data and semantic web technologies. And I'm really happy about Claria and Odyssey. They're trying to do all this, to develop those technologies, and they want to contribute to other projects. So that's something that we need to support, and we also need to promote for other people from other projects. So there is also some work on automatic metadata linkage to ontologies and external control vocabularies, and the idea that we'll get a linked open data cloud operational after some time. And we also started to use knowledge graph for the machine learning. And why we need artificial intelligence for that? I realized that this technology is new, and there is always discussion about semantic web for last 20 years, but it's not really. It's basically something for nerds. It's not adopted by researchers on a wider scale. So what we can do in this respect, we can use artificial intelligence to learn patterns from researchers, and we can try to build and train models. And we can basically learn some knowledge from researchers and apply artificial intelligence to do the job automatically. And that's something that already exists for named entity recognition task, for data mining, for topic classification. And it's basically coming to the state where it's more or less going from experimental stuff to production. So everybody can use it, and it's quite reliable nowadays. So we can build these multidisciplinary knowledge graphs based on those technologies automatically. So we can facilitate development of new projects with economic, social sciences. We can also take ownership of their own data if they'll see value in this. Like I mentioned, project called Clean Infra, and this project was finished like 5 years ago. However, there are a lot of developments that could contribute to this project right now. So, of course, it's difficult to imagine that this artificial intelligence will do job on highest quality without input from humans. So, and also we need to think how to control this artificial intelligence, because it's just black box. It does God knows what, nobody understands. So we need also to think about tools. So basically, it's called human in the loop tools. So we need human to check all results. We need to verify pipelines. We need to see what those artificial intelligence pipelines are producing, and if quality is good, we can use them to retrain models and to increase quality for automatic recognition. So just a few citations. Yeah, I put this Albert Einstein citation about computers. So computers are incredibly fast, accurate, and stupid. Humans are incredibly slow, inaccurate, and brilliant. Together, they are powerful beyond imagination. So this is what we should do. We need to combine efforts together with computers. We need to teach them how to do processing of information and how to create well, semantic links and to do other jobs that usually consume too much energy and power and time. So this combination of artificial intelligence and human intelligence can form something like superintelligence. So just very briefly to explain the process. So if there is some black box AI system, so it does some job, and there is human who is getting results and giving feedback, and those feedback is coming back to AI system, and machine learning is being retrained, and on next stage it will come again to human, and human will verify results again. So this is closed loop, and this is what we need to get really high quality results for artificial intelligence system. And to provide this functionality, there are a lot of annotation tools that is being used in different projects. And this one is called Hypothes.is, and this is really great project where Herbert contributed in the past. So basically, it's a plugin for your browser that everybody can install. And after installation, you will get possibility to highlight any pieces of text in your browser on any web page. And you can create annotation that could be downloaded as JSON-LD. So which is great. It's semantically compliant, and that's something we can use for the systems of artificial intelligence immediately. So another tool, I already mentioned this tool a lot of times. So it was created in Japan. So there's also kind of international collaboration because we contributed to its development. And this tool is very interesting because you can create any kind of labels. And those labels, after being creation of trained model, you can recognize automatically. So this is kind of black magic that does recognition of all components from medicine in this example. So why, again, a Dataverse network could be used as a solution for Metaverse? Just to repeat a little bit, so there is persistency. So we know how to archive and move objects from one Metaverse space to another virtual world. And we also know how persistent identifiers work. And even more important, in Dataverse, we have layer for files. So if you want to publish files, they can also get a persistent identifier. And this is the way how you can share the same object in different virtual realities, in different virtual worlds. So you can move it from one to another without problem. So this interoperability layer also should allow to build smart contracts, and we have some preliminary implementations of data management permissions for Dataverse, and that's something that should be we need to work more on this functionality. But still, the problem is human resources. So this is why we can't use Dataverse right now without applying artificial intelligence. So how we are going to speed up this process? So there is a library called Spacy, but there are a lot of libraries for natural language processing, and this is one of the most popular. And I already showed you some example how it works, how named entities can be recognized in the text. So it has a lot of trained models already, and that's something everybody can use. There are a lot of examples. And basically what it does, it does recognition of named entities. Like in this example, it's able to recognize organization names, geographical locations, and person names. And all of this information could be stored in Dataverse, and also can be linked to a semantic layer. So it can get linkage to, let's say, Wikipedia, Wikidata, or GeoNames, or whatever control vocabulary, or Cosmos. And this information is available immediately after it's stored in Dataverse as JSON-LD, which is great for people from Odyssey and Clara, because they can run all these semantic queries and they can get much more information from it. So I did some experiments and I've created projects in Doccano, and here you can see there is Odyssey portal and Harvard Dataverse. So basically what I did, I just started to harvest metadata from available Dataverse instances, and I did automatic recognition of all entities, and it's here. So this is example how it works. And in the Doccano annotation, there is also a nice web interface that allows to change entity if it was recognized wrongly, or if it was not recognized at all. You can always just to link it to some entity, and in this example you can see how it works in general. So it's basically, I did experiments with Dataverse and null network, which is in Dutch mostly, well, a lot of metadata in English. So still, it works for, I believe, for 12 languages now automatically. And after we see that there is something, some wrong matches, we can always correct it and submit to the system and retrain model. So next time it will be recognized properly. So I already mentioned that all of this information should go inside of Dataverse. However, there are a lot of interesting things that people already created in Dataverse, and it's in structured data. So for example, in this dataset, there is keyword called legal research. So legal research also was put in annotation, and after Doccano started to recognize these specific terms as a keyword, because it was used in this context. So basically, we can use all metadata, all keywords that Dataverse network already has to train those models. So just to illustrate that what I'm trying to describe here is not a dream. It's all realistic. It's all possible. So there is a new project. It was basically initiated by University of de Paris in France, and directed by Professor Yves Rosenholz, and it's about COVID-19 museum. So there are a lot of researchers from France and also other countries are joining now, and they want to create public service that will respect ownership of all digital artifacts, and it will be virtual space. It will be metaverse where all metadata related to the pandemic collected and interlinked. So it's really interesting project, and it has a lot of potential because we can also prototype some things and we can understand how it should work. And after we can share this knowledge with other projects. So in general, this museum is not only for researchers, it could be used also for artists and for citizens, scientists, and for different kind of professionals who are interested in this topic. And yeah, so currently there are like three different tracks for demonstrator. So there is Instagram workflow, and also newspapers coverage, and Corona pages investigation in Wikipedia. And why it could be interesting. So as you all know, we got locked in this lockdown, and we spent a lot of months sitting at home. So there is also interesting, there are a lot of interesting things for researchers to understand how society reacted and how it went. And for example, if you can collect some drawings from Instagram, and in the same time we can match with news workflows, news flows and media flows, what is discussed on television and by different people. So we can see there is a kind of relationship, right? And we can see people watching some terrible news. They started to make those drawings and publish online in Instagram and on Twitter and in other media channels. So that something is possible to collect, and I just prototype things, and I used a simple Dataverse instance, our distribution specific for this COVID-19 museum. And also Hypothes.is was used. So people got possibility to also to create some annotations for drawings that people created during pandemic times. And there are also interesting applications that we started to think how to build. And one of them is called Media Timeline. So I hope it works now. I will just try to show you what it's about. It takes some time. However, what it does, it's basically building timeline based on all materials stored in Dataverse. So it's querying Dataverse. It's basically semantic search engine. So I don't know if you can see, but now I'm querying on COVID, but it could be any keyword used. And basically you can browse through media channels. You can see also screenshot is created automatically by this workflow, and screenshot also is saved in Dataverse, so it's archived basically. And this information like summary, like title, date, it was extracted automatically by pipeline. And you can easily imagine that this technology can be used for any kind of Dataverse that has visual materials. So it has really great potential to be used in different applications for museums, for example, and also just in a way, it's also possible to use for Metaverse right now. If you'll put a handset, and you can also browse through this timeline, and you can read all materials. Yeah, so I will go back to my presentation. Oh, sorry, something went wrong here. Okay. Yeah, and just last thing, so Peter mentioned that it was not very easy time for me, and because of this war, of course, everybody in Ukraine feels like in this music, and I just wanted to show the state of mind of my own mind and mind of people that live in Ukraine now. Hope it works. Okay, I'm coming back, and yeah, basically I'm ready for questions if you have some questions.
Thank you very much, Slava, for this very wide-ranging talk. It takes my thoughts back to earlier sessions we had about the archive of the future and how that is driven by new ways of scholarly communication. I remember one workshop presented by Herbert together with Andrew Treloar from Australia a couple of years back. You can see in your presentation that time moves on, and you paint, yeah, how should I say, even possibilities that are occurring or will occur in the years to come. And as you assured us, many of these possibilities actually are not unrealistic. They in principle already exist. But let me kick off the questions, because I didn't see many questions appearing in the chat. That is indeed, what is the time you mentioned somewhere? This could be in 10 years, this could be in 20 years. You also showed possibilities that are already there now. But how do you expect that these developments will gradually take shape? And also then, and more pragmatically, which of them, because there are many, and an institution like DANS and many other, let us say, scientific data repositories have also an element of tradition in them and some conservatism. So we, and I believe that we have spoken about this also in the past. It will not be possible for such an organization as DANS-KNAW to embrace on all the new technologies and all the new possibilities at once. But what should be the next step or the first step to take?
Yeah, so this is really good question, and this is exactly why my presentation called Building Collaborative Network Using Artificial Intelligence. So it's even not necessary for DANS or other people to do more than we're doing now, because what we need to do, basically, we need to allow people to use annotation tools, and we need to convince them to use artificial intelligence and machine learning. So we can even start to build those models right now, because we have all information available in metadata, and most of data repositories, they already have good metadata. The only thing is missing is linkage to semantic concepts, and that's something that we can embrace. We can basically ask them to use kind of annotation as a service approach. There they can provide those annotations. They can create new labels, and we can start to recognize and to recognize keywords, to recognize entities, and create metadata automatically. And those metadata should be, of course, checked by experts like DANS and other institutions. So it's basically, we are, I think, on the right path right now, and we just need to do more about those machine learning tools and annotations, and it will come. So after Dataverse, after Archive in the Box will emerge, and I'm pretty sure it will emerge in Europe and after in the world. So we'll get hundreds of installations easily in the end of this year. And after people will understand that there is possibility to enrich metadata and to make metadata, to add interoperability to metadata, that's something that we'll start to use. And we'll come to these semantic search applications where people can find information, even searching in different languages without keywords that basically mentioned in metadata.
Thank you. I see a question in the chat by Peter Kirali. Peter, would you like to just read also your question aloud?
Yeah, sure. It was not clear for me whether this annotation tool runs locally or it is a service somewhere.
No, it's a service that I started to work before the war, and it was done in the context of Clara project, which is common infrastructure for arts and humanities. So this tool is just integrated with Dataverse in one of distributions. So you can get this tool installed in your place out of the box, and there is also possibility to connect it to pipeline that does harvesting from Dataverse and publishing complete annotations after NLP pipeline. So there is a kind of reusable tool already that will be released at some point.
Yeah, great. I could imagine lots of use cases for that, at least in my research. The other question is, what do you think? Would it be possible to put this timeline into Dataverse itself? So it as an alternative search interface?
Oh yeah,
I could imagine it.
Yeah, it's
nice.
You mean pipeline timeline application?
Yeah. So when I log into Dataverse, I just go to Dataverse. I could change from this current search to timeline, and I see the current activities in a Dataverse.
Yeah. So it's basically why I created this timeline. I really believe that this current in the current state of development, Dataverse has enough functionality to be connected to any visualization tool or any analysis tool, because it just uses JSON-LD as communication language. So it's not only timeline. You can imagine any kind of D3 or any kind of library that you can easily connect. I really believe even without doing programming, so you can just do it automatically because it contains all information about ontology, information about fields, and you just need to create kind of automatic mapping between interface that application understands and between Dataverse, and it should work. So in principle, doesn't matter where application is, just connected to Dataverse somehow.
Yeah. Okay, thanks. And I have a third question, which I haven't yet written down. What do you think about the carbon footprint of blockchain?
Well,
isn't it a
I think it's a question for next presentation, probably because it's well, of course it's emergent and a lot of people rely on it now, but it's not complete. So we really need to think about some extensions of blockchain, and I just tried to explain how you can use blockchain in open science, and it's really necessary, for example, to establish ownership. So the problem of our traditional internet, that you can basically download any image, and after you can upload and publish on your own website, and basically this is a way to steal things. So it should be not happening in new internet, in this metaverse.
Yeah. Thanks.
I have a question. Do you hear me?
Yes.
Ja, René, ga je gang.
Okay. Hi. Hi, Slava. Good to see you. And very interesting. You covered a lot of things in your presentation. My remark has to do with the fact I'm a member of the DANS training group, and I see some colleagues also in the call here. And we did a brainstorm last week, and currently most of our trainings have to do with data certification, making data management plan. So a lot of it, the F and the A in the fair data. I'm not sure, but I think your work is, what you presented now has much more to do with the I and the R, to make data interoperable, reusable. And it would be great if we can have another talk with you to see what kind of the things you mentioned, how can we translate that in some knowledge or expertise we can transfer to our, I would say maybe customers of DANS. So I already looked to some links you provided, and I thought, oh, when I'm going to, it will take me a couple of days before I can use the tool, and why should I use it, and what's the relevance, and is it relevant for projects we do? So I have more questions than answers, because you really gave a very, what Peter already said. You provided a picture of a landscape that I don't know where to go now, but I also think that that it is very relevant for the training group in DANS to look in what can we do with it. And you know all these things, but we also have to think about how can we then make it usable for our community. And that's just a remark, and also an invitation, and also to talk further on it, and also to also that we should take, of course, into consideration to find the focus, because you cannot do anything. Is it experimental? Is it already mature enough? And who is waiting? What kind of questions are we posing and answering? Just a remark, but also to complement that you provided us with all this new landscape. At least for me, I don't know how other people think about it, but for me that was really an opening up for instance, and some new things.
Yeah, thanks, René. And I really think that we need to introduce those new technologies to people, and we can also think how we can help other data repositories like DSpace, already mentioned, Zenoda, basically to get some tools that were produced by us, to get it installed and used for their own purposes. So this is how we can get them on the same ground, and we can try to train them, I think, if they have interest in this, of course.
Okay, let's continue this discussion at another occasion, I think. Yeah, that would be great.
Thanks.
Yeah.
I just, René's remark raised another question with me. He mentioned communities that may be interested in this. But I think there's quite a lot of difference in different communities. And you mentioned in your presentation a couple of times the Corona Y community as one community that is probably consisting of early adopters. But would you see other communities that we might that might be among the more early adopters of this of these kinds of technologies that you were showing?
I think any community doing something with Semantic Web should be interested in this development. Really, it's kind of a way also to emerge their own technologies.
You did also mention Claria once, at least. I don't remember exactly.
So in Claria we have a few working groups. So we are working on control vocabularies, and we're trying to match requirements. And what I'm describing here, it's also based on Claria work. So we want all components to be integrated, connected together, and also talk the same language. So it's coming, I think, to those communities. And I see a question from Thomas, so probably you can elaborate.
I don't. Yeah, there it is. Yeah.
Yeah, absolutely.
Thank you, Thomas.
So, yeah, so in this vision you paint, which you've done very nicely, as from my side at least, you mentioned Dataverse is talking to one another, effectively allowing for cross communication, and it doesn't matter which door you enter from, you can still ask your question effectively. So more like more like a central oracle in a certain way, I would say. In order to accomplish that sort of that level of interoperability and connectivity, I would say you would need some components in between, maybe some cross-indexing. I'm assuming there's standards involved. I mean, that's just engineering, and I understand that. But is there already some sort of consensus or idea or thoughts how to achieve that level of connectability which you're looking for, which you're describing?
Well, there is no agreement yet because it's really in the experimental stage, and that's something we basically started to build only now, right? So we're building those nodes in the distributed network, and the question how to connect everything is still on the table, and I believe that's something that probably will be discussed in DANS internally and also outside. So projects like Odyssey, they have exactly the same requirements, how to get all stuff from Dataverse as linked data, and how to make those interfaces to access those data.
Yeah.
So that's something still in discussion.
All right, clear. And are we the only one, is DANS as an organization the only one involved with this, with developing this particular vision, or is there like a bigger fish somewhere in the food chain?
Well, I would say DANS is touching, of course, touching some components, but what I'm trying to show here is kind of really high vision, and it's basically, this is where I think everything will go in like 5 or 10 years, depending from technology development. And now you see it's after COVID times, like natural language processing is really emergent because of deep learning and other kinds of developments. So we just need to join on train in the right moment, and probably they can deliver something back to us, and we can go quickly in some directions. And we can, because we are basically, we are collecting data, and we are doing great job on high quality data. So all this data can be used to train models, and they can improve any kind of pipelines that people will start to use.
So just as an additional question after that, I'm okay with giving someone else the microphone. Would you say that our focus should be on delivering a proof of concept here, a working proof of concept, or would you see our focus more heading towards creating consensus with everyone who's involved with this?
Yeah, I would say our job now to show possibilities, and we're not able to do it alone, you know. So we really need people to understand what we are doing, what we are offering, and to do it together in a collaborative way. So we need Harvard, we need Dataverse, we need everyone to jump in this train and just to follow us, and probably they will come with new suggestions. I really believe that after we'll see possibilities, they'll bring to us a lot of new options that we need to consider.
Right, thank you.
You're welcome. Peter, you're mute. Yeah.
Yeah, I was searching for my microphone button. I don't see further questions. I don't know if there's anybody who still has something to ask. And if not, then I would like to thank Slava again for this very broad vision, and with lots of interesting challenges ahead. And I would like to thank you all for attending. And perhaps as a very last thing, I would like to say that in the afternoon, we have another DANS workshop. I will type in the link for more information there, which is a data trail workshop on data management tools for archaeologists. And in case you have the stamina and the interest to attend, please see if you can still participate by registering. So, Slava, thank you very much, and perhaps we'll see each other in the afternoon.
Yeah.
Bye bye.
Thanks. Bye bye.